Hello and welcome to IABSE in Conversation, where I, David Knight, talk to eminent and interesting designers, structural engineers, and academics about what inspires them and their life and their career. In this episode, I'm delighted to welcome Mitsuyoshi Akiyama as my guest. Professor Akiyama is a structural engineer and academic who is now professor at Waseda University, where his research covers concrete and earthquake engineering for bridges, as well as issues of safety and reliability of structures. He chairs IABSE Commission 6, which covers sustainability, and is currently organizing the upcoming IABSE Tokyo Symposium. So Akiyama-san, where did this all start? Was there a particular experience in your childhood that pushed you into a career as an engineer?
Okay, hello everyone. My name is Mitsuyoshi Akiyama. I'm professor at Waseda University in Tokyo, Japan. Specializing in structural engineering. So as David mentioned, I'm studying about reliability and risk assessment of civil infrastructure systems, seismic design of concrete structures, and life cycle analysis and maintenance of deteriorating structures. So my career has been deeply influenced by past events such as the Kobe earthquake in 1995 and the Great East Japan earthquake in 2011. So these disasters demonstrated the importance of designing structures that can withstand multiple hazards. In addition, during my field investigations conducted after these major earthquakes, I realized that many structures and infrastructure systems exhibited significant deterioration. So this highlighted the need for a life cycle approach in design and maintenance. So it's an honor to have the opportunity to share my work and ideas with you today. Thank you.
That's great, and it must have been so influential as a young person to experience those earthquakes in person and be quite rewarding now to understand the impact of that and what work we can do as engineers to help mitigate that in the future. And you started your career working in industry at Nippon Koi. What do you take from working in industry and how do you take that back into academia? How does that transition work for you?
Yeah, actually, I only worked in bridge design company, Nippon Koei, for only 1 year after
Right.
getting my master degree. But, it was a very special time. In 1995, as I mentioned, we had the Kobe earthquake.
Mhm.
And our seismic design code was completely revised in 1996. And I began to work at the company from April 1998. So now our design code introduced some new method, such as dynamic analysis of bridges.
Mhm.
So, but fortunately, I did it during my master works at Tohoku University. So I was in charge. I was actually very freshman, but I was in charge of dynamic analysis, and I could learn how to design real bridge only for my only for 1 year experience, but I could learn a lot in practical field. And this really helped me to conduct research in academia.
And you've since spent about 25 years now working in academia. What do you find is the most inspiring part about that? Is it working with young students or is it pushing the boundaries of knowledge and research and making the world understand a little bit more about the science?
Yes, yes. And of course, this experience helped me to expand my research field. And also, this is very good when I work with my student and I try to reduce the gap between academia and practical field. So also, since I became associate professor at Tohoku University, I have been working in the development and revision of the design specifications for highway bridges. So I know the real practical design. So I believe I could give very good suggestions to code writers.
That's really interesting. And I also noticed on your CV that you've have visiting academic positions in the USA and in China, and you're obviously heavily involved in IABSE internationally. How important for you is international collaboration in the way that you work and talking outside of Japan about the work that you do?
Oh, it's a really very good questions. And so to expand my research field, I always need some new perspective. So when I stayed at Lehigh University in 2008, before that, my knowledge is always focusing on, my study is always focusing on earthquake engineering and on the ground motions. I didn't do any research about multiple hazard. But very fortunately, I could work with Professor Dan Frangopol at Lehigh University. He's a father of life cycle engineering. And I knew, so now it's a really good time to expand my research field, including life cycle perspective and sustainability. It was a time to start study on sustainability.
And that is what the international side has brought in. And you've become a chair of IABSE Commission 6, and you look after various task groups within that, but around sustainability. Can you talk a bit about how important sustainability is for engineers and what IABSE hopes to achieve with Commission 6?
Oh, yes. Our primary goal is to promote sustainability in structural engineering by developing tools and framework that integrate environmental considerations with engineering design and practice. So I aim to focus on reducing carbon emissions, improving resource efficiency, and enhancing the resilience of structures. So a critical aspect of this work is the application of life cycle analysis to ensure that environmental impact are minimized throughout the structure's entire lifespan, from design to demolitions. So now in our Commission 6, I think task group 6.1 is the most active group. Now currently Professor Alan Cornell is chair of this task group, which which is working on the impact of climate change on structures and the infrastructure system. So this includes assessing reliability, risk, and resilience from a life cycle perspective. So this work aligns closely with other efforts in the global structural engineering community, such as an upcoming report from the American Society of Civil Engineers, led by Professor Dan Frangopol of Lehigh University and Michelle Ghosh of the City College of New York, and Fabio Biondini of Politecnico di Milano. So in addition to addressing climate-related changes, our commission is also placing a strong emphasis on reducing carbon dioxide emissions during design, construction, and maintenance phases. So current TG 6.6 carbon footprint of bridge and infrastructure construction project. Chair is Marcus, and TG 6.7, sustainable structures to foster climate change mitigation and transition toward carbon neutrality. So chair is Helena. So these two task groups contribute to these challenges. So by addressing these interconnected issues, we aim to contribute to a more sustainable and resilient built environment. The point is, so for climate change issues, so now there are several technical council and task groups, committees, but mainly in structural engineering, they are evaluating the effect of climate change on structural performance, such as task group 6.1. But also now I believe it's a time to include other aspects like new materials, how to use new materials in the structural design, such as carbon negative or carbon neutral concrete.
It's fascinating, and it's a really vital topic for the world. I'm really pleased that IABSE is taking such a focused view on and working through the issues. And what about you? What is next for you as a practitioner and academic? And what plans do you have for the future and the future of engineering?
So we try to reduce the gap between, of course, academia and industry. So one way is by providing practical guidelines, case studies, and analytical tools. So we enable, Commission 6 enables engineers to adapt sustainable practices and respond effectively to these issues. Like, for example, in Japan, now we are exploring how green infrastructure, such as natural flood control systems, can work alongside gray infrastructure like concrete dams. So this integrated approach offers a sustainable and effective way to mitigate flooding risks. This is just one example, but by sharing these insights through IABSE, we hope to inspire engineers globally to adapt similar strategies. So Commission 6 can serve as a platform for collaborations by bridging together experts from different countries and disciplines. We facilitate the exchange of innovative ideas and solutions. So this collective effort helps shape the direction of structural engineering and ensures that sustainability becomes a core priority in our field. Of course, there are many new challenges and assignments.
And that feels like a really good place to leave it. Aki, thank you very much. Thank you for a fascinating conversation. Mitsuyoshi Akiyama is a member of the International Association of Bridge and Structural Engineers. IABSE is a group of designers and engineers and academics that is passionate and inspired by the world around us. To find out more, head to our website, www.iabse.org. Thank you for listening.